This is carried out by another significant algorithm called iterated soft thresholding algorithm, ISTA, also referred as thresholded Landweber, TL, algorithm. ISTA is a combination of the Landweber algorithm and soft thresholding. To minimize Jx, consider first the minimization of the simpler objective function. Because Jx in 8 is differentiable and convex, thus one can obtain its minimizer by setting the derivative with respect to x to 0. The derivative of Jx is given by setting the derivative to 0 gives a system of linear equations. So the minimizer of Jx in 9 is given by. However, it is not able to solve these equations easily. Since GPS data is a very long, then H will be very large matrix and solving the system of equations may require huge memory and computation time. Moreover, the matrix height H is not invertible, or ill-conditioned. By using the majorization minimization, approach to minimize Jx in 10, solving a system of linear equations can be avoided. At each iteration k of the approach, a function gkx that coincides with Jx at xk has been found. A majorizer gkx has introduced that can be minimized more easily without solving a system of eqs. A function gkx that majorizes Jx by adding a non-negative function to Jx. When gkx coincides with Jx at x equals xk, the non-negative function added to Jx should be equal to 0 at xk, then gkx to be. The function which is added to Jx is clearly 0 at xk so that gkx equals to Jxk as required. To ensure the function added to Jx is non-negative, for all x, the scalar parameter alpha must be chosen to be equal to or greater than the maximum eigenvalue of hth, i.e., alpha greater than or equal to max hth. Then the matrix alpha ihth is a positive semi-definite matrix, meaning that Vt, alpha ihth, V greater than or equal to 0. Now, using procedure, to obtain xk plus 1, function gkx is minimized. Expanding gkx in 12 gives. Note that the quadratic term in 12 is simply xtx instead of xththx. Therefore, we can minimize gkx more easily. Hence, by using procedure to obtain x value at each iteration is given by Landweber update equation as